Alrighty, so before we go into the JSON thing, before we go into the UTF-8 stuff, I should say, we should talk about the JSON source package thing. So yesterday, Josh, Arson, and me were like spitballing like different naming conventions. So there's two things I want to get out of this. One of them is I don't want to give a super attractive name to it because I think we will eventually, or we might eventually ship an actual OOP for this thing, and I really don't think they should be in the same package. That seems very weird. So effectively, we want to have a name that conveys that it's a source package, that you know what you're getting yourself into when you're consuming it. And the other thing is that it shouldn't collide with a name that we will eventually ship under.
So why don't we think that for packages that don't have exchange types, shipping sources is not the right thing to do long term? Because if there are exchange types, it's a different ballgame. If there are no exchange types, if it's a library,
Yeah.
I think many people would actually prefer sources, especially with this nice trick where you're gonna make all the types internal.
So-
Basically, then I don't have dependencies. I compile it with my assembly. Customers can choose whatever other version they want if they have an app. I mean, it solves many. It's actually quite nice.
Define exchange type.
Something that would show in public APIs.
So currently, JSON.NET types like JObject
Yeah.
are used exchange types all over the place.
Yes, I know. But we are talking about shipping the reader and writer.
But currently, we're talking about shipping the entire file.
Oh, the entire.
Yeah.
Okay,
But I
that
mean,
So
complicates
something like
it.
JDocument could be considered exchange type.
But let's just assume for the sake of argument, the only thing we would ship is just the reader writer, right? The problem that you still have is you still have bloat, and you still C# only, which basically means I think it doesn't work for everybody.
Sure, I agree. I'm not saying that we shouldn't ship other packages.
You
I'm
said
just
long term,
saying
right?
that
To me, but as soon
I
as you
would,
ship,
I
two
would
of them-
never switch to the DLL if I
Well, we
had
would
to
not
start.
remove the source package, right? We would just not promote it. I mean, it will always be there. But I think the problem is, given that source and binary are different axes, we cannot put it in the same package because you have no way of choosing. So they have to be different package IDs.
Yes.
So that's why I'm saying, from my point of view, whether we do it long term or not is almost irrelevant. You just have to pick a different name.
I agree, but so that one I agree.
Okay?
What I'm not sure about is trying to hide it and make it temporary and whatnot. I think it's a very nice long-term solution, and we should just append that sources, and basically, when you search for the component, you can either get the sources or the DLL.
Yeah. I mean, so the one problem with source packages in general is that we haven't really done it a lot, right? So like, I don't know what all the shortcomings are. My concern is that we will find more issues, and then it's like, well, how do we take this ever back, right? I mean, so the only two things that I know of is just bloat and like language specificness, right? There are potentially other issues. Like, I mean, effectively, it only works for cases where you literally make the type internal.
Yeah.
As soon as somebody makes something public,
Yeah.
it's falling apart fast. So, following what you suggested, Christoph, you will basically have like, I don't know, system.text.json.sources.
Yeah. Having said that, I do think that it's a very valid point. I would only do it for things that are basically libraries and no exchange types. I mean, technically you can exchange anything, but like in practice,
Yeah.
JSON reader and writer, they shouldn't be or won't be exchanged.
Yeah, I think just for our point of view, like I think the reader and writer is not enough. Like we have to get, I mean, for 3.0, in order to make this actually fly for partners, you would at least have to include the serializer.
Well, I wouldn't.
Which you can probably get away with most of it not being exchanged, but I mean, like you look at JSON.NET and ASP.NET, for example, the thing that configures your serializer, well, that's going to be in the public API at some point.
Serializer settings
Yeah.
is always fun.
I mean, but we could do something like, hey, if you want to use it as an exchange type, use the DLL. But if you are not planning to do it, just use the source package. What I meant by exchange types, there are some things that are like fundamentally exchange types. There's no reason to, span or memory.
Well,
There's no
index or
reason to
range,
make
yeah.
it internal and not have it as an exchange type. Like
Right.
that's completely non-scenario.
But on
Versus
something like
JSON.
on something like the reader, like we talked before about, I think decimal got cut. Yeah, so decimal.
No.
Oh, decimal state. So big integer. Like we didn't put get big integer on it, and we're like, it's an easy extension method for someone to write. Well, an extension method means it's now an exchange type. So every type that we've ever written is an exchange type to an extension method.
Can be.
Or
That's
to an
what I
extension
meant.
library.
Yeah,
Sure.
that's what I said. Like every public type can be an exchange type. The question is, I mean, is it the primary scenario or it's
Yeah.
kind of a
Like, for example, like index and range, there's absolutely no point in shipping sources.
Yeah, exactly.
Like this type makes absolutely no sense unless it's an exchange type. Versus this one is like, yeah, you can put anything in your signatures, but are you likely, right? And I think if we look at JSON, I think the number one thing that is very likely is the JSON settings thing, right? Because it's basically the number one thing you have to agree on with everybody. You can probably get away with putting this in a dictionary of string object or something, but like, I mean, at that point you're really butchering the feature in order to ship sources rather than doing the right thing. Like,
But looking at what we have today, serializer settings, JObject, JToken, and things, even JSON reader writer, text writer are
Right.
shown up in public API service
Yeah,
in
so-
our SDK.
so if I had to guess, so here's what I think will happen. We have to ship something for first party and early adopters to allow them to use JSON. We will eventually be forced to ship this thing as a new. I think that we can try to delay this because I mean, if you look at how we can ship OOPS, there's only two ways to do it in my opinion in the same way. Because the biggest problem with OOPS is the evolution, right? Like if you don't churn the API service, if it's frozen, which is basically what span was, it's not horrible. The only complication with that is like, well, you need to know pretty much upfront where the types will live because you also don't want to fuck with the type forwards, right? So you need to basically know what the exact shape of the feature is and never touch it again. Or the thing is purely OOPS. For index and range, we know, well, we will always have a type forwarding issue because it has to be encoded, but we can probably lock down the surface area pretty quickly. This one, I'm not sure how soon we can lock down the surface area. So I would say, to me, the source package is more like this bridging thing until we have a proper OOP. Once you have a proper OOP, why would you not use the OOP?
To not have dependencies on a package that can cause problems. It's always
I think though that the fundamental problem with that is that you basically force your ecosystem to make a choice. And I think the only other downside with the dependency is that it really only is a problem for .NET Framework. Or any other platform probably ships it in box at some point. So your dependency effectively disappears, but the fact that the platform already has it. Which is the other reason why I don't think it's horrible to have that as a package. So that being said, I
will
think
something like system collections immutable work where it is OOP and inbox and the API is not frozen?
yeah, but it's a good example of something that is effectively a pure OOP. Because I mean, even on .NET Core, there's a one-to-one mapping between the implementation assembly and the framework assembly, right? For index and range, it will never be like that because these types have to live in call it. We cannot OOP call it, so you have to basically ship something else that just type forwards. At that point, you have the split where you can never add APIs to that. And the problem with JSON is that we might get away with that, but the problem is always when you evolve the API service, you really have to be sure about everything, right? Like you need to know like if we ever split this assembly into two, for example, you're screwed.
Yeah.
Like, and that's kind of the thing that has broken us in the past, left and right, and that's why I would be kind of worried to ship an OOP until we know what the API service is. So, for example, reader, writer, and serialization might end up with different assemblies. Might not be, right? I don't know.
So in an effort to time box, back to the name.
Yeah, so I think system.text.json.sources seems, I don't know.
As our first source package, it seems we incur too much risk for us to put it in system namespace and publicize it that heavily.
Yeah,
That shows up next to the binaries right in search.
I agree with that. So until we have some experience publishing source packages, we
Yeah.
shouldn't, like, that may be a good long-term plan
Yep.
if we start doing it, but for the first one that we're really just using it as a handoff to first party and select third party, Microsoft compatibility seems like a good prefix to get it out of the way. And to Christoph's point of he would want to take the source package and never reference the DLL. Once we're happy with things and we understand our flow of publishing sources and we understand the consequences of publishing sources, we can always relist it as system text JSON sources.
Yeah. So my proposal, I mean, I think originally proposed Microsoft compatibility, but we don't really have that thing yet. The other thing we could be doing, because we already done this in the past, is Microsoft.bcl.json.sources. Like, it's a horrible name, but who cares?
Compatibility, so first, my care level about the name is super low. because it kind of doesn't matter, correct? But the thing is that compatibility is weird. Like,
It's
why?
basically the idea is to convey down level. Like it's similar to the async targeting pack where we basically gave you something for 4.0. It's just like here's some. Yeah.
Meaning, so you mean portable? It should be Microsoft portable that sources that
Yes.
JSON.
So how do you feel about Microsoft.bcl.json sources? Because that's the
BCL
Microsoft.bcl.
doesn't mean anything outside of Microsoft.
Well, we have shipped packages before with that. They are basically like that. So like all the down level oops we have shipped before, like we did this for the get a waiter stuff for tasks.
Well, we may have done that before, but does it actually mean anything to anybody?
No.
If not, then it
But that's the thing. Right? Like that's given that it's our first source
It
package,
does
it's
appear
kind
on
of a win.
Wikipedia.
So why not just basically change the first node to Microsoft, but then keep the rest
Well, that's the thing. Microsoft.
the same as sources?
So the two things we just have is Microsoft.compatibility.json.sources. The other one I just threw in was Microsoft.bcl.json.sources.
Why not Microsoft text JSON sources?
Just replace system with text and add sources. System with Microsoft.
But you don't want the namespace to be system in Microsoft, I hope, right?
You don't want what?
You don't want the namespace to be Microsoft, I would hope. In the actual package.
Yeah, probably not. It would be easier to transition later if it's system.
I can live with that. Good enough for me.
So the namespace differs from the package name?
It does that. Just ignore it.
Yeah,
I'll
it
get
does
to you in a
ignore
minute. It's a loose connection somewhere.
Is that the intent? This namespace would be differing from the package name?
No, it wouldn't be. It would just be in the package name. Namespace would still be system text.json in the sources.
I thought we wanted to change the namespace in the sources so that it wouldn't conflict when we have it as a public init core app.
Why would you do that?
Because if you include the sources and you reference that core app,
Why would you do that?
because fair enough.
Like that seems like at that point, what you really want to do is in your multi-targeting thing say, if target from a net core app, don't reference the package.
That's fair.
Wait, so the namespace will remain the same as whatever was with the binary namespace?
That just wasn't the plan that I heard. So.
Because I mean that goes back to what Christoph said, right? I mean if you let's say you multi-target between full framework and net core app 3, the easiest thing for you is to have the same source code and just say when you're targeting and when you're compiling for full framework, add the package dependency, and you don't have to touch any of your source files because of the same API source.
Okay.
That seems like a cleaner approach rather than forcing everybody to, basically it's just easier to transition between the two.
Another thing we could do is basically just do like Microsoft sources that,
I
and
prefer that.
use this kind
Yeah,
of.
so the other reason why I don't like that is like it seems very weird to have sources at the top level team because it sounds like technology at that point. It seems like an orthogonal decision point. So if you have Microsoft.sources.json, it's like, what is it? What does that mean? Does it convey the
You
thing?
replace Microsoft sources with system, and you get to the DLL version of this technology.
Yeah, but then it's like, well, System.sources seems like an
Right,
area
but
in the
again,
PCL at that point.
If the long-term plan of once we figured out what it means to be publishing source packages and maintenance on them, etc., is to go to the name of the package.sources, then having sources be at the end and in our interim solution seems better.
Yeah, we would. All right.
So Microsoft BCL JSON sources. Microsoft BCL is not an organized prefix.
So not Microsoft.bcl?
Sorry, dots were implicit.
Yeah, I mean that's
It's like
honestly
vowels in Arabic.
that's the ugliest name I can come up with, and it kind of satisfies what I want to do. Like, I mean, the thing with Microsoft.bcl is people know what it is. It's basically down-level crap. Like, it's effectively what it has meant in the past.
I mean, we can reserve the prefix down level crap.
So why not Microsoft.portable.text.json?
We don't have that term today. I mean, you could do that. Seems a bit over the top because we use that. To me, like portable is like it sounds like PCLs, which it's really not about.
I mean, we refer to system memory as a portable, containing portable span. And that's English word that people can understand rather than BCL.
I think we have enough names now listed up that we can probably close this over email. Like let me just summarize the three names that we have, and then we can just make a quick decision. We don't have to do this right now. But I think Microsoft the text.json.sources was also not a bad idea. We can also live with that. All right, so then let's move on to char8.
Let's. Can you actually refresh this real fast? I made some very brief changes while you were talking. So I want to start off with motivating the char8 type. I won't bore you by making you read that whole blurb at the beginning.
You just read it to us.
Yes, I will read it to you and lull you all to sleep. In this document, I use the name UTFHR just to be more explicit, but char8, whatever, the name doesn't really matter to me. So the purpose of the type is consider it as equivalent to how char represents a piece of a UTF-16 code unit. Char is basically similar to uint16, but a text code unit. Char8 is similar to uint8, but a text code unit for UTF-8 specifically. The reason for this is just like you don't want to treat arbitrary binary data as UTF-16, you don't necessarily want to treat arbitrary binary data as UTF-8. And let me put an asterisk on that statement. When I say you don't want to, I mean the data that's coming in from the wire, you have a web server, something like that, that data is binary, right? The client has told you you should interpret this data as UTF-8. However, until you actually make the determination that the data is UTF-8, it's just binary data that you can't really do much with. The purpose of the char8 UTF-HR data type is to say, if you have a sequence of these things, the sequence represents text data, like data that I actually know to be like real, honest-to-God UTF-8. The reason that this matters is, and I speak at length about this in this document, and I'll just briefly summarize here. You don't necessarily want to encourage developers to create applications, web servers, where they read in some read-only span of byte from the network, they perform some manipulation on it, and then they throw that to a back-end server, a back-end database, something like that, which now looks at that exact same read-only span of byte and then takes different action based on it. An example of that is if I tell you, here's my username and I've submitted this in UTF-8, and you call things like to lower on it, great. Like your application believes that the lowercase version of that blob is something. But if I have crafted that blob in such a way that it's not actually valid UTF-8, at the time that you pass it back to the database layer might normalize it in a way that your application's not expecting.
Right.
And at that point, your database and your application now disagree on what the actual text says, which leads to your application having undefined behavior. The motivation for read-only span of char8, as distinct from read-only span of byte, is to get developers to not treat arbitrary binary data as UTF-8. That said, if we did want to say, like, screw it, read-only span of byte is our representation of UTF-8 data, like I can go over at the end of this how that might change the entire API surface, but that's the general motivation. If you read through the document in your spare time, you'll also see how this compares to what Swift does, what Go does. I won't really go into that right now. Can you just look for the word struct in the document?
I mean, to me, it's also similar to in C.
One more.
Char star is both.
Yes.
I have some amount of binary data and I have some amount of text.
Yes.
And that any questions I answer on Stack Overflow that are in C are invariably explaining to someone that char star and char star are actually different types.
Yes, and in C, the way that developers generally work around that in C is it's very common to use Hungarian notation, not just in parameter names, but also in locals. And that's a way that C developers keep track of whether this char star happens to be binary versus text data, but that's not a very .NET way of doing things. We tend not to require our developers to use Hungarian notation.
Emo, can you make the screen bigger or the text on the screen bigger?
I can.
So anyway, what you see on the screen right here is well,
Very large word called slice.
yes. What you see on the screen right here is the actual definition of the UTF-HR type. This type is 8 bits in size, just like a byte. In fact, it's backed by a byte. It wraps a byte effectively. And there are, it's basically, think of it like a new integral type. There are conversion operators between this and all of the other integer types, including byte, char, and other things. The conversion operators are checked in this proposal. I'm open to alternative ideas here. That means that if you have an int, which is -1, and you try casting it to UTF-HR, you actually get an overflow exception. If you have an int that's -1, you cast it to a byte, and then you cast it to a UTF-HR, you get FF.
Why is the dummy field an int?
That's a typo. That should be byte.
Well, the way this works is this is generated by reference assembly tool.
Yeah.
The type doesn't matter. It's basically just a primitive.
No, the type does matter, correct?
No,
It's
size
supposed to be the
size
size.
doesn't work
In
otherwise.
the reference assembly, it doesn't matter.
I believe the C# compiler requires the reference assembly to be correct for size of to work.
Nope.
No? Okay, great.
Well, little
Little
size
size
of is unsafe,
No,
sometimes safe.
it's
Weird. What matters in a reference assembly is do you have any fields?
Yeah.
And then do you use generic? Like if you have if you have a generic, do you use them in fields to make cyclic layout checks work? Blah blah blah. There's a bunch of rules we just applied to sort of reference assemblies, and that's why there's
Private dummies about definite assignment, not about.
Yeah, there's like this is this basically do you have any field?
But if little size of can read this, then it may be.
yeah. As long as we make little size of work, like it doesn't really matter here. So as you can see from the APIs, like most of the APIs are actually just conversion operators. There are also things like equality operators, like the typical stuff that you would expect a struct to have.
Right.
If you scroll down a little bit just past the type definition, you'll actually see there examples of what that would look like. In this case, you can see that things like addition, subtraction just work. And the reason for that is, just like with byte, char, and other types, when you add, there's an implicit widening to int. So if you have UTF-HR plus 10, well, you get an int as a result. That matches the behavior that you get today if you were to say like some byte plus 10 or some char plus 10. Equality works as expected. You can compare a UTF-HR against an int, just like how you can compare a byte or a char against an int. And again, that's due to the fact that there's an implicit widening operation.
So what's the purpose of doing math on char? Like I'm trying to think when I've seen it done on char, and it's generally like when you're like checking for upper and lower casing and you're the A to Z and
Well,
are there other
A
reasons?
to I.
A to I.
So you're parsing an integer. You read the character, you subtract.
I can't remember the separation between upper and lower case.
Yeah, you're subtracting.
Yeah.
You're subtracting the value of char 0.
Either that or I mean, what other reasons do you have for doing math?
But
Or
that's
defined?
mainly the reason.
All right.
You'll often find that arithmetic operations aren't that common, but comparison operations are.
Right.
So I want to say, like, if my char is less than or equal to like capital Z,
Right.
that's actually pretty common. But this shows what some of those would look like in practice. You'll see the only one that actually fails is the one that's second to the bottom, which is what I mentioned earlier, where you have a negative number that we try casting to a UTF-HR. Because that's checked, it leads to an overflow exception at runtime. Everything else will work as expected. Okay, so now the question is like, so how does this actually relate to byte? Like it's all well and good that I might have a sequence of UTF-HR inside my application, but ultimately, like I want to do something like write this out to a file, write this to the Y or something like that. What I had proposed, and I know we're going to be jumping around the document a bit, sorry.
So can I interrupt for a second?
Yeah.
You said at the start this is not the same as Rune. For those
Yes.
of us who aren't aware of it,
Sure,
can you very
for sure.
briefly, before we plunge into
Yes.
even deeper?
Yeah, so the difference is let me start with system.char. System.char is a UTF-16 code unit. What that means is it is a 16-bit integer where a sequence of such integers represents hopefully well-formed UTF-16 data. The code unit by itself may or may not represent like a single letter. So I can have a system char represent the character E, or if I want to represent an emoji, for instance, I require two system chars for that. UTF-HR is similar. It's an 8-bit code unit where a sequence of them represents UTF-8
So it's any arbitrary 8-bit with chunk of a valid UTF-8 sequence.
Not necessarily. It is any 8-bit UTF-8 code unit. However, UTF-HR by itself is not checked for validity. For example, like the byte FF is never, ever, ever valid anywhere in UTF-8, ever, under any circumstance.
It's an 8-bit wide chunk of a byte array that you are claiming is UTF-8, but may or may not be.
Yeah, so you can absolutely cast FF to UTF-HR, but if you ever try throwing that through an API that expects UTF-8, it's going to blow up.
Whereas a rune is what, the whole emoji?
A rune is the entire scalar value that is represented by one or more code units in sequence. So, for example, an emoji character, generally speaking, is one rune, which is probably going to be 2 UTF-16 code units or 4 UTF-8
And we have no
units.
parallel equivalent in the char16 world.
Correct. A rune is generally thought of as a sequence of code units where the sequence length might be 1. A displayed character, like a glyph, is a sequence of 1 or more runes. It's basically collections all the way down.
But again, we have no equivalent in the UTF-16 world of a rune.
Well, I wouldn't say that, right? Like UTF-16 and UTF-8 are really just given a sequence of runes. How do I encode them in binary format? So you can always take a UTF-16 sequence and turn it into a rune sequence. You can always take a UTF-8 sequence and turn it into a rune sequence.
Back to schedule programming.
By the way, those APIs already exist.
It applies equally to UTF-16 and UTF-8, right? That's basically what you're saying. It's not tied to one of them; it's both of them.
Correct.
Rune is similarly a UTF-32 code unit.
No, that is incorrect.
Strike that.
The .NET definition of a rune is a Unicode scalar, which is a subset of a UTF-32 code unit. Like it is impossible to make a system.text.rune that wraps a value -1. The constructor forbids it. Whereas a UTF-32 code unit is basically just an int. By the way, that's the Go definition of a rune. The Go definition of a rune is I am literally a 32-bit integer. I am type def as int. Can you look for the word fixed and then go to the second match?
Is that as big as it gets, the code?
There. So this is showing what I meant earlier about like I have a sequence of UTF-8 data and I want to do something like write it to the stream, write it to disk, something like that. The idea is we would have a bunch of useful extension methods hanging off of read-only span of UTF-8 char, just like how today we have a bunch of useful extensions hanging off of read-only span of char. The extension method I'm showing here is asBytes, which basically says, if I have a read-only span of UTF-8 char, immediately project it as a read-only span of byte. It doesn't perform validation. It doesn't need to because it assumes the input's well-formed. It's basically the equivalent of memory marshal.cast, but without requiring you to call into memory marshal, because memory marshal is what we consider to be a dangerous API.
We already actually have that asBytes extension method, right? Because it operates on any arbitrary T.
No, we ended up not making that an extension method. We ended up making that a regular method, a regular static method in memory marshal.
I see.
And the reason that we never made it an extension method is because it allows you to inspect private members of T.
Sure, got it.
But this would be an extension method that is absolutely equivalent to memory marshal asBytes. We would just expose it as an extension method because it's convenient and safe. What this code sample is showing is that if you were to call asBytes, like you're getting back a span that literally just points back to the original data. If you call fixed on each of them and compare the pointers, they're the same. The other thing that this is showing is because we would actually have a type UTF-HR, we can enlighten certain APIs just like we do for char today. For example, read-only span of UTF-8 char.toString we can actually make it return a string that represents that data as UTF-16. Just like how today, read-only span of char.toString actually stringifies the data. Compare that with read-only span of byte.toString, which literally just returns the text read-only span of byte sub length.
And the same for cast to string?
There's no cast to string here. There's no cast between read-only span of char to string. There is an implicit cast the other way. If we had a UTF-8 string type, that a parallel cast would exist.
Okay.
But I'm considering in these API proposals that such a type does exist, but I'm not really going over what that type would look like as part of these proposals.
Right.
By the way, because of this issue that Levi just mentioned, I'm literally removing read-only span of byte right now and removing support for UTF-8 because it's impossible to debug the code. And developers, so on Monday, there are actually developers starting to use kind of a pipeline framework that I created. It still has, I basically wanted to make it UTF-8 enabled. So I used read-only span of byte. But since it's impossible to debug, I was debugging one thing with a developer on our team, and she was so confused that like without this feature, basically the only way to debug is when you have a problem, you go and like change your code and create a debug string.
Yeah.
Switch to memory view.
Sorry, can you elaborate? Like, what was the issue you were trying to debug, and how is it worse or better?
Well, you have a bunch of methods, and they take read-only span of byte.
Yeah.
And I know that it's UTF-8, and now inside the method something doesn't work, and I want to know what's inside. And
basically, toString doesn't work.
And yeah, exactly.
You can look at them.
So that would be solved by, just to make sure, like, I'm not really going to get used to UTF-HR, but there are other ways to solve that. You have a toString for read-only span of byte, assuming it's UTF-8. That solves the issue, right?
And no, but then debugger doesn't show it, so I have to call this method.
You would have to call it, yeah.
I basically have to call it manually, so I have to now change temporarily while I'm debugging this method. I have to change the source code in it, and then I have to remember to remove this to UTF-16 string.
One fix we could be doing is that we just say on span the toString method gives you effectively back something that looks like a hex view, where you have the bytes on the left-hand side, the text on the right-hand side, and you can at least look at the data.
Historically, that's been very difficult to debug because I've been trying to debug the UTF-8 logic while having a hex view like that, and it's very painful.
Exactly, it's the same, correct?
Yeah.
Why is the hex view? Because you still see the text, right?
Well, a hex view is just going to be hex. Right now, I need to go consult an ASCII.
No, like an actual hex viewer would show you the bytes on the left-hand side and the text on the right-hand side. And that's what you would return in the string, like formatted effectively.
Oh, so assume that read-only span of bytes is ASCII?
Well, you would basically, as soon as if you have a string, you have the text viewer, like when you click on it, you just get it formatted nicely.
Yes,
don't get me wrong, it's not as convenient as having a tie, but I think we could make that fundamentally better than what it is today.
Obviously, if you have surrogate pairs, it's not going to help.
Yeah. So what?
If you have surrogate pairs, it's going to look like garbage.
Well, like, I mean, a hex view is a hex view, right? So like, it will work. The only problem is that it's not as compact. So if you have like 5 locals, it doesn't render nicely. And then the other problem that you still have is that I think honestly the bigger problem is just the types, right? Like if you look at the method signatures, if you say I take read-only span of char, I can kind of have that by knowing what it is. If you take read-only span of byte, I kind of have to know that you meant UTF-8.
Yeah,
right? Like
and I did want to go over later what it would look like if we were to use read-only span of byte everywhere, because it is a viable proposal, and languages like Go are considering that, but they are running into problems with it, and I want to share at the end what those problems might look like if we were to do that as well.
So my question is like, how widespread is it already? Like, maybe I'm wrong, but like, given that we look at a lot of these APIs, I have this impression that we use read-only span of byte already a lot for UTF-8.
Kind of. You use it right now in the sense that I have received data directly from the wire, or I'm writing directly to the wire, and I want to do parsing on that data as cheaply as possible without any type of intermediary.
Well, and one additional thing, all these methods are try methods, which kind of basically you can look at it. Well, if it happens to be UTF-8 text, I'm going to parse it. If not, then I won't. And therefore, it's a try method.
Yeah. And to me, it's more about the, let's say we ship this, right?
Yeah.
Now you have, a gazillion options on what the APIs can expose, right? You can take UTF-8 string, you can take read-only span of char8, and like you can take read-only span of
Well,
byte.
so all of those
So how do we-
APIs are, all of those APIs have UTF-8 in the name, but they're actually all ASCII, and will always be ASCII for all time. The reason that they'll always be ASCII for all time is because fundamentally they're working with not text. Fundamentally, they're working with things like integral types, and they're just saying what is the ASCII representation of this integral type, like as it's traveling across the network.
Yeah, and that's talking about implementations, and we're talking about what, like, can a user make sense of that effectively?
So we already have this situation in UTF-16 world. We basically have a system string, and we use span of char as a slice.
Yeah.
There's nothing more to it here.
But we don't use span of byte.
Yeah,
Well,
so
we,
I don't
as
think we have too many-
Levi was saying, we don't really use span of byte.
Okay.
We use it for those few methods that, like try parse basically is the only one. Do we have any other?
Well, we have
That's
UTF-8 parser and UTF-8 formatter,
Yeah.
and then the only other place that I can think of that we have it is the JSON stuff right now.
Yeah.
And so if we add this type, what we would do going forward is we would say if you're reading UTF-8 text, you take char8,
Yeah.
And if you're reading from the wire, you can take byte, and then you should in the parameter name say UTF-8
Yes,
or the
and
type name say UTF-8.
I did talk about that briefly at the beginning of the document, even though we didn't go over it here. I basically laid out like if exactly what you said. If you operate on bytes, assume it's coming from the wire, assume that it might not actually be UTF-8, and you're required to do validation under the covers. If you take UTF-8 char, you can assume it's UTF-8 because you can assume someone in front of you actually did that check. Now you can't make such an assumption that you can AV if the data's bad, but you can at least be a little fast and loose with how you do things.
So when you say validation, if we ship this type, then does that mean all previous read-only span of byte APIs now required to do validation?
All read-only span and byte APIs are already required to do validation. That's the behavior that currently exists today.
Validation for what?
To make sure that the data is valid UTF-8. That every API we have that uses read-only span and byte and treats it as UTF-8 already today does validation.
I'm a little unclear of what validation means in this case. You mentioned that char8, you can treat it as valid UTF-8, but not completely rely on it being valid. So are we doing any better than Hungarian?
It's not a Hungarian type thing. It's because if you're working with discontiguous buffers of data, the super sequence that's generated from all of these buffers being concatenated together may be valid even if the individual buffer itself isn't. For instance, if data's coming from the wire and it does happen to be valid UTF-8 but just happened to get split like in the middle of a multi-byte sequence, the individual sequence that you're reading like logically represents part of a valid UTF-8 string,
Right.
even though that span itself is not valid.
So
When I say valid, I mean ill-formed.
So what value am I getting from saying a char8 is valid? Like if it's not necessarily actually more valid than a byte
That
sequence.
you wouldn't
means-
expect
yeah.
I have 3 bytes remaining markers in a row.
Yeah.
Okay.
It means you should never see that, but more importantly, it means that you can pass it to something like your database API, and you should have an expectation of how that API will behave. As in every component that you pass that sequence to should behave in a well-defined manner and not cause bugs in your application.
So you were showing us this method as bytes. Are we gonna have equivalent as char8 that does validation? Basically, I would imagine a method that takes a span of bytes, runs validation through it, and basically reinterprets it as char8.
So there are actually can you look for the word text writer in this document?
I mean, my initial thought on that would be encoding.utf8 exposes that it is of type UTF-8 encoding, and we could put on that validate, which takes in a byte and outs a span of takes in a span of byte and outs the span of char if it's valid.
Yeah. So let's.
sorry.
Are you saying we basically gonna have an API like
That-
what I said?
Yeah.
But it wouldn't be an extension.
Oh, okay.
Yeah,
Sorry.
yeah.
That's I meant. Are we gonna have an API like?
So
Yes.
here's
So let's actually come back to that in a few minutes. But you were saying
concern about
sorry.
expectations. If we are going to use that API to validate the span of byte turns into valid UTF-8 char, then it's guaranteed that the span of UTF-8 char is valid.
Kind of,
But
yes.
in some cases it will be, some cases it won't be. So
Unless
what's
you
the
call
value?
memory Marshall.
Well,
Yeah.
The thing, if it's throw or it's try API.
So, but
Yeah.
then the person accepting the UTF-8 char still has to validate.
No. So
No, necessarily.
also it's the truth is somebody can create an array of char8, put random values that don't actually represent UTF-8 text, and we cannot do
And
anything.
you could do that with an array of char right now. And to be perfectly honest, I'm not really worried about that because no one does that with char arrays in practice. So I'm not terribly concerned
So
with people doing it with char8 arrays.
Bottom line is, do APIs that accept UTF-8 char, read-only span of UTF-8 char,
Yeah.
do they need to validate the bytes?
No.
But if they accept read-only span of byte, they do need to validate.
Yes.
Honestly, no. Like, I think that's I don't think you have to validate after the type code instantiated. I mean, it's the exact same thing you have today. Somebody can call a constructor, pass in valid data, do private reflection over the field, and corrupt the object state. But you're not protecting yourself against that by
So
saying every
just
single
to
time
argue
method
against
is called, you don't
it does-
verify your state.
One way in my mind it adds more value than Hungarian is that if you are careful in your code or your library's code, that when you translate from read-only span of byte, read-only span of char, you do validate. At that point, if you do that, the compiler will make sure that nobody is using an unvalidated char.
Well, I mean, that's the type system, basically.
Yeah.
Right, so
Like
it's better
your-
than Hungarian, right?
Yeah.
Yes.
So to your question, Asim, like that is, I guess one could make the argument that it is a little bit of an academic distinction, because if you're doing something like a text manipulation or processing API, you might already have to interpret the text just as a matter of your API doing its work. At that point, you're kind of already doing validation anyway. One example of that would be like the JavaScript escaping routines that we were talking about the other day. Like if we have to determine if some particular rune is in a whitelist, well, the only way that we can determine that is if we actually decode the sequence, which necessarily involves validation anyway. So some APIs do have an academic distinction. But what I was getting at earlier is say that again, like you're talking to your database through an API, like Entity Framework, something like that. Like if that takes a read-only span of UTF-HR as a parameter, that API is very clearly saying, I only expect you to give me valid UTF-8. Maybe I'm not going to do validation before I actually split it out to the wire. Maybe I'm just going to project memcopy and go. But if you give me invalid UTF-8 and it makes its way to the database, you now have undefined behavior. And again, if you read through the document, I have links to some interesting CVEs resulting from that exact thing.
Okay, so let me drill down a little bit further on that
Yeah.
question. I have the API, JSON writer,
Yeah.
which accepts read-only span of byte today.
Yeah.
There's no escaping involved. It just copies the bytes that you give me directly to the wire.
Yeah.
Now you add an API overload that takes a read-only span of UTF-HR. That forces the byte one, based on your guideline, to now validate that it's valid UTF-8.
The read-only span of byte should already be validating. Nothing that I'm proposing here should change what existing API should be doing.
So now, okay, that means that all.
Yeah, you're breaking into jail.
no, I mean, because I want to clarify because.
Yeah.
Yes, the the JSON reader needs to now valid. It's taking read-only span of byte. It needs to make sure it receives legal UTF-8 data.
So,
I would go a step further and say, like, if you ship
Yeah.
this type, you shouldn't have the API.
there might be valid use
should
cases
only
for
have
it.
UTF-8.
So I don't want to say never, right? Like there might still be valid use cases for it. Something like JSON reader, JSON writer, it does make sense to expose to the developer, like I actually am expected to be writing to a network or reading from a network. And at that point, like it might be more convenient to work with bytes and with UTF-HR. So I don't necessarily want to say that you should always use one versus the other, but we want to make sure that developers have an expectation of what kind of data they're getting back. In your particular case, your UTF-8 JSON reader, I believe you have a property which is raw value, which is exposed as a read-only span of byte, correct?
Mm-hmm.
Like here's the raw stuff I got from the wire. I haven't done any type of inspection on it yet. I can't tell you if it's valid. that's totally fine because you're exposing it as read-only span
Sure,
of
so
byte.
the,
Like
the,
it's
reader, the
network
reader
bytes.
is not the concern. I'm talking
Yeah.
about the writer.
You think anything that involves with like you know it's a string like
Yeah.
property name.
Yeah.
Why would you ever go with only span of byte at that point?
You wouldn't.
You would
Yeah,
always.
I would hope you wouldn't.
That's what I'm saying. I think the API you just talked about, you just wouldn't have.
Yeah.
Like you would say, write property. Well, you accept the read-only
So
span of
the odd thing is, if you had a byte, you expect validation to happen. But if you have a UTF-8, you don't.
No, because the idea is you're
I would-
rely on
I
the
would
fact
validate
that-
Someone's already validated
Yeah.
it, is what it comes
But
down
there's
to.
no guarantee.
well,
Either way.
No, but I think you're throwing out the baby with the bathwater, right? Like, so you could we can make the same argument for any type that has a constructor that takes logically a non-null element, right?
Yeah.
Can you reflection inspect the fields and set them to null? Yes.
Right.
Is now every method on this type required to check the field is not null before any doing operation? No. You just say if you instantiated this type in the same way, you know it's valid. So if you got UTF-HR by using memory marshal and do a direct cast, well then you didn't construct the type properly.
So if that was the case, I would agree with you. You can just create an array of
Yeah.
char8 and assign,
Yeah, it's-
like
you can totally do that, but
you don't have
Right,
to
so
use
there's no-
exotic
there's-
so
unsafe
absolutely.
APIs.
So it's
One
not
is
one
saying
the
valid,
array
the other
would
is
be
saying
just
not. The
zeros,
only change
right?
we change
So-
was the
No, you
type.
can
I have an answer
assign
to your
values.
question.
You can assign 25,
Yeah.
0, 0, 7. It's
Yeah.
probably not valid UTF-8.
um,
It is valid?
so I can actually answer your question, Asim.
No, don't follow
To your very specific question, the only time where a read-only span of UTF-8 may not be valid, just like the only time where a read-only span of char might not be valid, is if it happens to represent chunked data within a larger piece of text, where that larger piece of text is well-formed. So say that I'm reading like the entire works of Shakespeare, and I'm just reading it in 4K chunks. Like one of those chunks might go across a multi-code unit sequence, and that's okay. But if I'm talking about something like the JSON writer, your JSON writer expects to take a full string as a parameter, basically, right? Like the read-only span of char or UTF-8 that you take is not expected to be a chunk of text. It's expected to be the text. At that point, you should assume no formedness.
I think I understand something. If I have two chars,
Yeah.
there are valid. I mean, I could cast into a char and for each of those and come up with something that wasn't a valid
Correct.
sequence, right?
Correct.
Okay, just like I could do the same for UTF-8.
Yeah. But in practice, though, again, the reason I'm not too worried is people just don't do that in practice.
I'm not saying it's something to worry about. I'm just
Yeah,
trying to
yeah,
clarify. Like you don't have to use unsafe code or anything
Right,
crazy to
exactly.
come up with ways of constructing
Exactly.
them.
Also, again, in my mind, like it does mean that as long as you're careful about at the boundary where you're creating these things, from then on, the compiler will make sure that you're in a world of safety. But that's how.
But
Yes.
the thing is, I would say the guidelines should apply for both.
Yes.
You have a span of byte, you validate. Span of UTF-8, you have to validate.
You don't
Because
necessarily.
nothing changed.
I-
Nobody can guarantee that it's valid now.
The
All you did-
reason that I don't want to force validation there is because the idea is if you're working within the safety rails that the language and the types are giving you, like we should be able to assume that the developer has done the right thing. And assuming the developer has done the right thing allows us to take shortcuts that maybe we wouldn't have been comfortable taking otherwise.
So what I don't understand is like, so they go back to like what Stephen and Christoph just talked
Yeah.
about. So are you saying the only case where you're having invalid UTF-8 sequence effectively would be when you just break characters apart? Is that the only case?
If you have a read-only span of UTF-HR and you as a developer have not done something like manually fudge with
Right.
the underlying data or like sliced it weirdly, like then that statement is correct. The only time you should ever have that is if it represents a chunk where these super sequences.
But that's not necessarily true, right? I got a binary from wire, I cast it to really span of char8.
You use memory marshal.cast at that point.
I see.
If you run it through the whatever API of this
Yeah.
is bytes, give me or turn a read-only span of
Yeah.
byte into read-only
Yeah.
span of
There,
char8.
there is.
That is the validation.
So let's
point,
actually
right?
go over this real
So
fast.
like,
What's on the
but
screen?
to your example, so if I construct an array
Yeah.
of UTF-HR
Yeah.
And you fill it with FF.
and I fill it with random data,
Yeah.
then I cannot construct like invalid values of UTF-HR. I just get a resulting sequence that is no longer well formed.
You can do that with char arrays today.
Exactly. So,
Yeah.
like in that sense, I think that's not horrible.
Yeah.
Well, okay, so I have to tell you, this whole validation thing, to me, it's, yes, today it's very inconvenient for a developer because I have to use Hungarian notation. Every parameter that takes read-only span of byte, I have to say it's UTF-8. And same for locals and fields and so on and so on. I don't have the debugger support and so on. And so, there are many benefits. I don't think validation is one of the strongest benefits. And the reason for it is that if my life depended on it, I have to validate anyway. If my life does not depend on it, because as a side effect, I'm validating because I'm parsing and I expect, digits. And if I find something that is not a digit, I'm, I'm failing. So
And that is absolutely
to
a fair
me, the
point.
main benefit is it makes programming using this type sane as opposed to very clunky. It's not really about safety and validation.
Well, but like going down that path, right? So like if you say the primary value of the type is to just have a different type so that people can have overloads and other things, then would that also mean that if you do validation, that you also get the benefit by losing perf?
I think the type conveys the exact same thing that we've created the notion of the strongly typed string for. It tells you this is what kind of data you should expect and this is what it means. So it removes the UTF-8 from the parameter names.
Right.
It says as long as you've gotten one of these in a sane way, the data is probably sane, the same way that if you have a read-only span of char, it's probably sane, but could be insane.
Exactly.
It basically makes me,
I don't have to code this defensively.
Anyway.
Yeah.
I don't have to code this defensively.
Yeah.
But if my life depended on it, I would be very defensive.
No,
anyway.
I guess what I'm trying to say is that so there's some overhead involved now because we do some validation somewhere.
So
someone
the interesting thing is, so yes, we're gonna have two ways to cast bytes to this thing. One is through memory marshal.
Right.
It has no cost and I don't get anything.
Right.
And then there's gonna be another one where I don't have to use unsafe marshal APIs.
Yeah.
And yes, there's a cost, but the cost is not very large.
Yeah.
So you don't care that we do some validation in this proposal.
Yeah.
You're
I
just
think
saying
that
I
would
wouldn't
be
sell it
basically,
as a overhead.
and if I notice that I have a performance problem, I just switch to marshal cast.
Yeah.
And then in the routine when I use marshal, I'm thinking, is it really UTF-8 text, or maybe it could be something else.
Yes, and I don't want to foreclose the ability for the developer to do that, right? Like I don't want to say, validation and conformance is the end-all be-all of everything, because maybe you're reading something from a local file on disk, and maybe, damn it, I know this data is trustworthy.
Right.
Like you shouldn't have to pay a penalty just to satisfy our paranoia. But regarding things like overloads and what the actual API conveys to you, like take a look at stuff like this that's on the screen right now, TextWriter. So right now, TextWriter is primarily written in terms of string and char. There are overloads of write that take things like int, long, and so on. We had already previously approved at a different meeting TextWriter.write of room. This is TextWriter.write of UTF-8 data. You can imagine that if we had a UTF-8 string type, there would also be overloads for that, but let's just consider span in memory for now.
I just want to clarify one thing, Lena. So you say TextWriter uses UTF-8 as its default encoding. That's not really a true statement. TextWriter doesn't have default encoding, which is abstract, and different derived text writers will use different things. So StreamWriter, I believe you're right that StreamWriter is UTF-8, but StringWriter is UTF-16.
Okay,
Well,
let me write that down.
StreamWriter actually takes a parameter, you can pass in encoding, and then it does transcoding on the fly, depending on what you.
Yes, but what I was trying to say, and what Steve corrected me on, is that if you don't pass anything, StreamWriter assumes encoding.utf8.
Yeah.
Okay, I'm writing that down myself so that I can correct it. Thanks, Steve.
Cool. But I agree. Like probably 99.9% uses of TextWriter are StreamWriter, so it's close enough.
Yeah. Okay. Thanks. So the idea here is, if you have an abstract text writer, which is probably a stream writer or similar that's using UTF-8 encoding under the covers, writing UTF-8 data to that writer should be free as far as transcoding is concerned. That's why I believe it might make sense to add these overloads onto the TextWriter base class. Maybe we don't add them on TextWriter. Maybe we only put them on StreamWriter. Like that's a conversation we could have. But the idea is, if your data is already massaged in such a manner that it's appropriate for just bit blasting onto the network, why would we stop you from doing that?
I have one question related to this, Levi. So we've had a bunch of conversations in the past, and I'm curious where you landed around the scenario of, you're ASP.NET and you've got a read-only memory of byte from the wire.
Yes.
And now if we have a method like this, presumably it's because you're going to write out some data that you got from somewhere.
Yes.
It's read-only memory byte versus read-only memory of UTF-8 What are your thoughts around that?
So span you can cast back and forth because you can use memory marshal.cast. Memory, you're kind of in a hard place, unfortunately. My thinking on that was, if you have memory of byte, for ASP.NET they're actually using a custom text writer under the covers. So I think they're actually in an okay position because they can just cast to their derived type and go. For the average developer, well, I shouldn't say the average developer. For the power developer who doesn't have their own derived type, that power developer would need to fabricate a memory of byte which wraps the memory of UTF-HR, which is possible but ugly to do.
And requires allocation?
I believe that can be done in such a manner as not to require allocation, but I'd have to get back to you on that.
You could do it with a memory manager that just mapped through the two of them and use things like that.
That's the allocation I was thinking of.
Yeah, that would be the easiest way to do it. I think you can get away without it, but I would have to check.
I mean, it'd be one object to hold the reference. It's not order in. It's order
O of one. Yeah.
Right.
And you could also pull those if you need to, but yeah.
So looking at this one, the first thing that I see of if TextWriter, because TextWriters have multiple encodings.
Yep.
The obvious thing on this is that encoding also should get, where it takes chars and strings and goes to bytes, it should take UTF-8 chars and go to bytes, and encoding UTF-8 says done. And then that lets the default implementation of TextWriter on this just say send this to your encodings magic.
Yes. So I didn't want to add it onto the encoding class because the encoding class has a lot of overhead and legacy that I don't think is appropriate for high performance applications. I had proposed a separate parallel set of APIs which operate on UTF-HR, byte, and char.
Right, but the problem is you need to make it fit for the places where they already took an encoding, and
yes.
And you can't ask it, is this encoding being UTF-8? You can only ask, is it the shared UTF-8 encoding?
Correct.
Sorry, Jeremy, just to understand that you're saying the existing encoding methods work to and from UTF-16, and you're saying we would need methods for working to and from UTF-8?
At least from UTF-8.
Yes, that is a good point.
So you would want get bytes of UTF-8, or get bytes that accepts UTF-8 char, read-only span of UTF-8 char, just like we have the one that takes read-only span of UTF-16 char. Mm-hmm. And then the obvious answer is UTF-8 encoding says return as.
Yes. I don't have APIs for that in this proposal, and now that you've mentioned that, I agree we will have to do something there.
But it solves the text writer. It gives us the default.
But what's the return type of the getBytes method?
It's probably span to span.
I guess, well, the one that we have that takes span in is that takes span of char in is it takes a span of char or span of byte destination.
Yeah, I mean we can think about this later, but there's an issue with today getBytes returns a new array. It's read write and it's yours.
Yeah.
If we want to reinterpret cast, then
Well,
depending on the encoding, you can do it or you cannot do it. And
right, we can do smarter things in other cases, but we would need to solve it for the stream writer that took an encoding that wasn't any of our shared encodings.
Yes.
We'll need to make the new virtual work.
Yeah.
And so that's the cost of this is we have to put something on encoding to be able to defer it through.
And by the way,
or do a double allocate.
I'm okay with that particular scenario not being highly optimized because I think it's sufficiently rare.
Right, because we would do what we always do in these cases.
Yeah.
We would override the stuff on most of our types and,
Yeah.
and everything.
And along those lines, like all of the APIs that I'm proposing here are very highly optimized for when the sequence is well formed, but these APIs might under the covers allocate if the sequence is ill formed, and then they have to do fix-ups under the covers. Again, I haven't optimized for that because it should never happen in practice, but just in case it does, I didn't want these things to blow up. Anyway, so yeah, binary writer and text writer are basically like two sides of the same coin. Rune is an existing approved type. It's already in Netcore 3.0 preview. There is an existing API on Rune. Can you scroll down a tiny bit, Nemo? There is an existing API on Rune, which is Encode, which takes a span of char as destination and outs the number of chars written. Here's a UTF-8 equivalent.
What do we call the method? Do we call it try and code UTF-16?
The other method's just called Encode. We could just make this an overload with the same name.
Yeah.
Because I don't think we'd have any type that would implicitly go to both of them, so we wouldn't add an implicit error.
I would go so further and say we must not have that because you would think people can overload based on these things.
It's the making sure that nothing that we have right now would ever make sense to have gone to both, and then we can add this overload, and now we have a rule that it can't ever because we would...
Why do we have... So this API is super low level and kind of ugly.
Yeah.
Do we need to have it on Rune? Like, why not put it on the UTF-8 type?
It already matches what's on Rune, but Rune hasn't shipped yet, right? It's only preview. We can rip the existing method out of Rune and put it on the UTF-16 type.
Right.
And I just want symmetry. What that looks like in practice, I'm open to.
Because I kind of cannot, like, this is an API for somebody who writes these, routines that actually people use.
Yes.
Yeah, then we shouldn't have those on Rune. But I get that, we already added the one for
But again,
UTF-16.
it hasn't shipped in an RTM release yet, right? Like we can change it if we want to.
Char, Rune, and UTFHR all have a relationship, and we have to just decide.
I know.
So memory extensions. The APIs you see here are basically just clones of the APIs that already exist as specializations for read-only span of char.
Right.
I don't think it makes sense to go over all of them, but there are some very specific ones I wanted to call out.
So I want to ask a higher level question.
Yeah.
So whatever these methods are, will I be able to get them in the portable system memory package?
I don't see why not, though the implementation might be less efficient.
No, you will not because the APIs are frozen.
Yeah, that's why I asked.
I mean, part of the question is, will UTF-8 char go portable?
I could give you implementations of these where the API names themselves might be different. Maybe it's not hanging on memory extensions, but there's nothing prohibiting us from making a portable version from making portable equivalents of these APIs. You might have to have if-defs in your code.
Yeah.
Or another package that has these extension methods
in the same namespace, in a different class.
That would work too.
But just to make sure, this is super important. That's what I said. I spent now a month prototyping something. I used read-only span of byte. And because of not having this, not having the debugging story and some other things, I'm literally removing it. I will add it back if I have it, otherwise we cannot use it. It's unusable. Read-only span of byte as text is literally such pain in the butt that I don't want to subject any developer on my team.
Funny that you mentioned that because I mentioned that I wanted to go over later what would it mean if we were to use read-only span of byte instead of read-only span of UTF-HR. There are two things that immediately fall out of that with respect to the APIs we're looking at right now. The first is that these APIs are no longer extension methods. They would just be regular static methods on, let's just say, the type's name UTF-8, right? You say UTF-8.toUpper, and then you pass in the read-only span of byte that you want to uppercase, right? The second point to that is that's actually kind of how Go works today. They don't have a concept of extension methods or instance methods hanging off of their slice types. Instead, they just have a class, a namespace, what you will, a package named UTF-8, and this package exports a bunch of methods to upper, to lower, blah, 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 that take byte spans and strings.
But this is idiomatic to Go. It's not very idiomatic to
Correct.
C#.
Correct.
So. I would keep like some of the ones that make sense as extensions.
Right. So I mean, the easiest answer is if you know, if we're making, if UTF-8 goes portable, right, then all of these things move to a different extension class, which would then ship in the same assembly as UTF-8, which would be like UTF-8 memory extensions or something.
Well, I would do what kind of a hybrid to what Levi was saying. Ship the UTF-8 type. They would be static methods and just keep them as extensions. And then UTF-8 type, it's a bunch of static methods. You can either call them as extensions or the static method syntax.
Again, I'm not really married to naming or where these things live.
Name spacing is the weird one because if we want it as an extension method on the span, then it needs to live in system. And his UTF-8 utility class here, he has in system text Unicode.
Yeah.
So I've written up the fact that we need to think about down level, but I would say let's design the thing independent of down level for the time.
Yeah. So one other thing I wanted to call out here is, so I mentioned that these are already equivalents of what's on read-only span char. 2 points. The first is look at the contains method. You'll notice that I have extra overloads that might not make sense at first. The extra.
Yeah, can you scroll up?
He's typing.
Oh. Scroll up to where contains is. Here it is. So 2 points. Contains, there is an overload that says, like, does the span A contain the span B? Well, there's a char equivalent, whatever. There's also an overload that takes a char and an overload that takes a room. And the reason for those overloads is because I think it's going to be more convenient for people to write something like, if my UTF-8 span dot contains single quote X single quote close parens. Like, that's already an idiom that developers are used to. I want that to just continue to work here. I don't necessarily want to extend that to being able to pass in an entire string, because at that point you have stuff like localization to deal with, you have transcoding, blah, 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 blah. But for individual chars and individual rooms, I think it's helpful to have those overloads.
Why would we have them on contains and not have them on index of?
It would be for contains, index of, starts with, ends with, another thing. I just didn't want to pollute this.
So I would say, till we have UTF-8 string literals, I think we need to have an overload that takes system string.
The performance of that would probably not be what people would expect, unfortunately.
But without it, it's clunky. It's super clunky.
Okay.
Okay, so maybe can we have the helper that you mentioned, like the literal dot UTF-8?
It's in the feature branch, but it hasn't been approved for 3.0 as far as I can tell.
But
what does it do?
It basically would do the slow path, basically just like taking the string if I'm not on the newest runtime, and on newest runtime would do what basically he's doing, which is it is a helper method for the compiler that just points to metadata.
So you can in the feature branch right now, you can do UTF-8 string dot literal open quotes hello close quotes. The JIT will recognize that method call and will emit the equivalent of loadster dot and will pretend that you had written the equivalent of loadster dot UTF-8 instead of just a regular loadster.
So what's the return type of this guy then?
The return type's UTF-8 string. It's part of the UTF-8 string work all up.
It's not like, so it doesn't matter what the method accepts, it just basically shortcuts the call effectively.
It doesn't just shortcut the call, like the JIT actually turns it into an O of 1 operation.
Yeah.
That's the key part. Because otherwise you would have to transcode every single call site. Which
one thing that I mentioned yesterday to Levi is that last time I talked to Mads about this, that this idea of target typing the literals, right, which I find not very compelling because it basically prevents us from adding overloads to existing methods that take string, because you never call them. Which is why I think in practice when we design overloads, like I think Jeremy brought this up, let's not have string overloads because they conflict. The argument would be, well, we have to solve this problem regardless, because we will probably want to have overloads for things that have taken string today. So I think we need either you have to live with the fact that the caller always has to cast, or we just say there's special syntax. But otherwise you write a literal in the source code, and in the code review you have no idea of knowing is this going to transcode or not, because it all depends on what the receiver accepts. And
I think that they're going to need some sort of
literal syntax.
Yeah.
Literal syntax.
I do have separately a proposal for what would look like, but it's a conversation for a different day. It's in our internal team. Though.
So, but the question is, while we are waiting for the compiler feature,
Right.
I think, I think the goal is, can we add UTF-8, slice support and make it practical for people to use? And I think without
UTF-8 string is not going to be shipping at the same time potentially.
well, I don't need for this method contains. I don't need the UTF-8.
But that method you're saying has a return time.
We could give you a method very. Let's talk offline. I can give you a method I think which is very similar to what you're asking for, but let's talk offline.
Okay.
No.
I'll just make a point that
contains-
literally I believe
Let me write that down.
the feature is not
extension
practical.
method
Yeah.
Where
without
value is strict.
Sure.
Because it's
So does this
So speaking about practicality,
Okay.
span of UTF-8 contain
Sure.
this?
so how married is this type to UTF-8 string? Like, would it be possible to ship this without UTF-8 string, or the basic
Yes,
here?
that is correct. It would be possible to ship them separately. However, when I was talking with Josh the other day, he thinks that the strongest argument is going to be shipping them together, and I agree with him. And the reason for that is, what's the easiest way to get a read-only span of UTF-HR? To start with a UTF-8 string.
Yeah, so I would disagree.
No, okay.
Sorry, I mean I would say that like if the UTF-8 string without UTF-HR is bad, but I think I would not hold this on UTF-8 string because then we can take things like JSON document and say that it takes UTF-HR and not byte.
There are compiler features that I would like to see come in before this hits, but I don't think that's going to happen. For example, there is a work item on the Roslyn team to say, like, I want to be able to have both a checked and an unchecked cast operator for a given type. That would be great, but timing's just not going to work out for this.
Yeah.
So
I mean, in general, like I think that. So what you said about UTF-8 string is the easiest producer for char8 or UTF-HR is, I think it's true if you have literal support. If you don't have support for literals, I think you're much more likely to have a byte array or a read-only span of byte you want to just reinterpret cast. I think that's a way more common way to get to the radius.
What you would do in practice, I think. So you're talking literals, right?
Well, I'm saying, like, I mean, like, how do people get a read-only span of UTF-HR, right? I mean, I would think, so even if we have UTF-8 string as the type, without literal support, you basically have to start with something else, right?
Right. You would.
In which case you would start with
you would need a helper method, which is basically like your own intern dictionary or something, which is what we had spoken about the other day.
Right.
Or if something's coming in from the wire, you would use one of the copy methods.
Yeah, but my point is that when you have a helper method, you control what is the type you're converting from.
Yeah,
right?
but
so you can bypass UTF-8 string effectively entirely. Right?
You know, UTF-8 char try validate takes in read-only span of byte and outs read-only span of UTF-8 char.
Right.
Like all we need to do is add one thing of turn these bytes into UTF-8 char.
Oh, they got the bytes.
They got the bytes, however they got the bytes.
But that's Emo's point.
You mean
to
from
get the
wire,
bytes, I need to have a literal support for string.
Yeah.
Well, I mean, I would say that like depends on how you think about this, right? Like I think
from the wire.
I think what Levi said is like
no, we are not
the most common scenario to getting a char today is from a literal. I buy that, but I think that only flies if the compiler has support for literals.
Yeah.
If we don't get compiler support for literals, shipping UTF-8 string doesn't help us at all, in my opinion.
Right.
My thing is of why we would ship UTF-8 char without if UTF-8 string is not ready this release,
right.
But UTF-8 char was, why UTF-8 char would make sense to be included is we can add you have bytes from the network, turn this into chars, now call new API that takes UTF-8 char.
But I agree with you. It's just we started to talk about the scenario of like literals and calling contains and whatnot.
And that's where I'm saying.
And I agree with Emo, UTF-8 string doesn't help you here unless there's basically literal support is the thing that I need for it.
Yeah.
That's it. I don't need anything else, frankly.
Yeah, let me rephrase what I said. We made the decision that the compiler will not have support for UTF-8 literals in the C#8 release, meaning for 3.0. Which means we could decide to ship UTF-8 string in 3.0. I don't think it biases anything.
Right.
I think that, so basically I would say that if you look at 3.0, we basically have to accept UTF-8 string was not going to ship. Which now means shipping char8 only makes sense if we believe char8 or UTF-8 char is meaningful enough without UTF-8 string. If we think they're tied at the hip, then that by extension means you have to wait for like.
It stops
3.1
us
or
from
something.
in this release polluting things with read-only span of byte when we would say in the next release they should have been read-only span of
Yes.
UTF-8
That
so
is something that
fixes
concerns me.
it makes us not have
I agree.
the ugly wart of dual inputs for the interpretation condition from the wire,
So that one.
and it lets you when
Yeah.
the C#
I agree that
8.1
it's
compiler
better.
comes
But
out.
it's better
you
than
can use
nothing.
the literal
It's
feature.
better.
Yes.
It's better than nothing.
Yeah.
But still, without literal support, the feature is not.
It's not as compelling.
It's not.
But there's always a race condition with the
Usable in
runtime.
practice.
There's the runtime, the framework, and the compiler and the language of when do things, and some usually they align together, but sometimes pieces go in different waves.
So, by the way, we had the discussion. I don't know what your thoughts are on it. I claim that we don't need runtime support.
For what?
If we just need compiler, and I agree with Emo or others that I think it should be explicit. But imagine that we had compiler syntax where you can, prefix U8 or suffix U8 to a string, and it actually returns read-only span of char8. That's basically what it is. Because it's read-only span of char8, it just points to the metadata. If you want to create heapable type from it, well, you're going to be making copy anyway, because it's going to be on the heap now in some other place. So, there can be a constructor for future UTF-8 string that takes this thing and just calls to array and copies, or not to array, but like copies the data. So to me, the kind of MVP for this feature is this type and literal support in the language that produces it.
Yeah, and I'm saying that us .NET Core 3 having UTF-8 char without Roslyn having the support is fine because the next version of Roslyn will work against .NET Core 3. We just, like, the other way around is the one that doesn't make sense.
It's weak and very unfortunate, but yes, technically, I agree with you.
If you have a date of release, sometimes one thing's ready and the other one's not. And I'm just saying that we shouldn't artificially hold this. That's all I'm trying to say.
Fine, I buy that. It's just I'm disappointed that we talked about the literal support for strings in C# 3 years ago.
So there are two other method classes on memory extensions I want to call attention to. The first is trim. Is it on the screen right now?
Yep.
It
It's
is.
above your one.
Yeah, it's you'll notice that the trim overloads are relatively pale compared to the read-only span of char equivalents. The reason for that is just the difficulty of implementing all of those other equivalents. So this is what I consider to be the minimum viable product.
Can you tell me what we're actually missing?
We're missing overloads that trim read. There are other overloads that take read-only span of char or UTF-HR, whatever, that says for any element in this sequence, trim all of those elements off of the span that you have.
Are we gonna have equivalent read-only memory of char8?
Yes.
Thing?
So
Okay.
if you start with a UTF-8 string, that can be, and this all works in the feature branch, that can be converted to a read-only memory of UTF-HR or a read-only memory of byte. Each of those can be converted to the appropriate spans. Additionally, read-only span of UTF-HR can be converted to read-only span of byte. Anything else requires unsay.
So you will need read-only memory of char8 overloads for
trim, yes.
Not only for trim.
No, because
I guess only for the
because of
yeah.
downcasting. Yeah.
We don't have memory overloads for anything else.
Yeah, only for the ones that have a return string.
Which right now is only trim. The other methods that are weird here, at least compared to the UTF-16 equivalents, are 2 upper and 2 lower, and I have a giant comment explaining why they're different. The key difference is that the 2 upper and 2 lower methods that take read-only span of char and write to span of char, changing case for UTF-16 does not change the number of UTF-16 code units. That means that you can perform that case conversion in place. The reason that it doesn't change the length is because we use what's called simple case holding under the covers. I won't get into the full details, but it guarantees the length will never change. UTF-8 is different. UTF-8, when you change case, you can expand the length of the string, you can shrink the length of the string. That means that this method necessarily behaves differently than the UTF-16 equivalent. So concretely, that
Can
means
you scroll to this method?
So concretely, that means that take a look at just 2 upper 2 lower. It's just after the comment,
including the comment.
Including the comment, yeah. Concretely, that means A, you can't pass the same buffer for both source and destination. If you do, you might corrupt your data. The UTF-16 equivalents do allow you to pass the exact same buffer. That also means that if we run out of room in the destination while we're reading the source and doing the conversion, we'll report false. We'll return -1 to you, and then leave the destination corrupted. Basically, I shouldn't say corrupted, but leave the destination partially converted.
Do we have any other places that we've added right to span that? Because most of the places that I've seen, we can check the length up front, and then we don't write anything. So either we give you a valid thing, or we're operation status and we tell you that we filled part of stuff.
So there are operation status APIs later in this document. I don't think we're going to get to them today, but they exist and they're written here. This was simply an analog of what already existed on memory extensions. Those methods today detect that the destination's too small, they return -1, and they just exit.
What are the existing methods?
The existing methods 2 upper 2 lower.
For what type?
Read-only span of char extension methods.
But these don't resize, so why do
they don't resize, but because the length can never change when you're doing case conversion for UTF-16, they know what the destination length requirement is up front, which means they can just return -1 if the destination is too small. I can't make that determination without actually walking the entire data, which means I can't return -1 eagerly. I have to do all of the work to do the case conversion and then return -1. But if I've already done all of the work for case conversion, why didn't I just start populating the destination?
And the existing methods are the extension methods?
Yes.
Because,
I would expect do it 2 in. Don't.
So O of 2 in?
2 in still in. You can always remember the first place that you actually had to do work, and then you get a copy of that.
So we could do that, but that kind of works against the value prop for having all of this UTF-8 work in the first place, which is I want to operate on data coming from the network with as minimal amount of overhead as possible.
But one thing we could do is say we have operation status APIs. They are for the I really want to deal with like non-contiguous runes and stuff like this, right? And then we have kind of helpers. They are not completely insane, like allocate every single time, but at least they either work or don't. They are the try equivalent.
Yeah, because walking it twice is fine. It's not like all you have to do is count the number of bytes you have to increase in the first walk. And I agree with Christoph. The operation status would be the one of you want it to do 1 in, and you're willing to pay the loop yourself. And if you just want it to work, we shouldn't go around corrupting, or we shouldn't go around writing the buffers and then saying, "Oh, I'm sorry, I forgot what I'm supposed to do now."
And that's fair. That's why I wanted to bring it up for discussion.
Yeah.
And maybe the answer is just we don't even have this. Like that's the third alternative, right?
I mean, if we shipped, we'd immediately get somebody saying, "Hey, you seem to have lost this in your feature parity."
Yeah. For things like UTF-8 string, this isn't an issue because they allocate anyway. But yeah, I mean UTF-8 string not 2 upper 2 lower.
Right. I'm just like someone would file the issue, and then we have to keep shutting it down, or eventually do the time walk.
Direct them to the operation status based APIs.
I see operation status APIs as something that we build on top. So, we have a prototype in CoreFX lab of text writer that takes transformers, and then transformers use operation status APIs to do all this magic for you. I think that's the only sane way to use the APIs.
Okay.
Again, I'm kind of, thinking it's not even kind of the line of business developer, but developer on the Azure SDK team. Are we gonna tell them to do this I mean, they're gonna be basically like, okay, I'm not using UTF-8 string anymore, because in UTF-16, I can just basically, two upper, two lower, and it always works. It can be chained.
Well, if you use UTF-8 string as an exchange type, everything just works as expected. It's just methods like this where you're operating on raw sequences, you have to be aware of the fact that you have to be aware of the underlying encoding.
Right.
And at
So
that point,
my answer
dealing
is
with it.
this should do exactly what encoding does. If we said that encoding needs to count and see how many bytes it will, if encoding UTF-8 counts the number of bytes before writing anything, then this needs to count the number of output chars before it writes anything. And if we said encoding is allowed to be messy, then this is allowed to be messy.
Okay.
Like
that's fair.
Exactly my, like, we need to have consistency with what we do. With if we return a negative number, that means we didn't do anything. Or if we return a negative number, it means I've probably destroyed all of the data that you originally had.
How do we keep from getting into a situation where developers might expect an operation to be O of something, but it's actually O of something else? I mean, documentation is the answer.
O of n is O of n, whether it's 2n or 3n or 16n.
Yeah, but the constant factors do show up in benchmarks. So.
I think, we have operation status APIs, and all complexity is very well defined. And then we have many APIs in .NET Framework where nobody can tell what the complexity is, and that's okay.
Okay, that's fair. Let's scroll down a little bit more then to the is well-formed sequence APIs. It's the last thing in this large block of code.
Sorry, Steven lost it. Well, we lost Steven because the laptop died.
Oh, this one?
Yeah. So we should.
I saw the battery notice and then didn't notice when it finally died.
Okay, so is well-formed sequence helper methods for both UTF-8 and UTF-16 that simply tell you, give me a span, I'll tell you if it's well-formed or not.
Why would we not make it return
the index?
Read-only span of char8?
Yeah, I would make. I mean, you can have the Boolean one as well, but then I would make a, try read that, like, you come up with something that starts with try, and either returns false if it's not well formed, and outs
the reason I didn't propose that here is because the caller has to do something in the else case, and I didn't really have a good feeling for a common pattern that everybody would be able to write in order to handle that correctly. Like what I had actually done in my own sample code when I was using this was I had an API which was, here's a read-only span of byte. If this represents well-formed UTF-8, project it as a read-only span of UTF-8 char and then just return that exact same thing back to me. Otherwise, new up a UTF-8 char array that contains this data, but where everything's been replaced to be well-formed, and then return a span pointing to that array.
But I thought a very common scenario would be, I call this method or something like this, and if it's UTF-8 well-formed, I do whatever I was doing, otherwise I throw an exception and I say, I don't know what you want me to do, because you wanted to parse UTF-8 JSON and it's not even UTF-8. Forget about it not being a JSON.
You could do that too.
And therefore, well, this API is really bad for it because it would require me now going through the same code twice. First, I check whether it's valid, and then I want to actually have read-only, span of char8 because I'm about to execute the method that
essentially we want to the success path from this should hide from the user the unsafe as.
Okay, so it sounds like what we actually want then are three different methods. The first is as written here, like given a span, like is this just well formed, yes or no? The second is given a span, try projecting it as read-only span of UTF-8 char and return false if you can't do it. And
I'm wondering whether the first one is useful. Because when I check whether it's valid, the next step is either I fail or I want to have already validated sequence. I never want to just go and
I would start with just the try one, and they can out underscore if they don't want the result.
Unless what is the scenario for just checking?
I'm a database layer, and I have some kind of validation turned on before I actually commit stuff to disk. It's all just bytes in the end, but I want to make sure the caller didn't give me bad data, because I'm running in a debug mode or something.
Then I just put underscore as well.
Anyway, the third overload would basically be always give me back a read-only span of UTF-8 If you have to fix it up, allocate a new array and give me a span to that array.
I would want a fourth one, which is give me a read-only span of UTF-HR or throw. So I don't have to write the try if block myself and throw myself.
Well, I mean, that matches the guideline of if you have a try, have a non-try.
Yeah, we could do that.
I don't want it to fix up, I want to throw.
Okay.
Even though the fix up one is also useful.
Yeah, I mean, and then so a fix up one may be useful. The assert this is valid and give it to me is useful. Try, but I don't know that the one that just hides, because obviously if you have this, well, I guess either one could be written in terms of the other. Of which is this doing the out underscore for you, or is the out one calling this and then returning?
So the actual underlying method, which isn't listed here because it's private, is return the index of the first invalid code unit, and also out the number of UTF-16 code units that would be equivalent, and out the number of UTF-13 code units that would be equivalent.
Oh, so
that's the underlying method.
So it's already destroying registers. That's fine.
Yeah, exactly. It's fantastic. By the way, that method, once we clean it up, does eventually need to be made public because everything is written in terms of that. But whatever. If we were to have an overload that says, fix up whatever you need to do and then give me back a span of UTF-HR, would we be okay with that just allocating? Considering it really shouldn't, this should never happen in the first place. The only reason I'm doing this is to fix up bad data.
I think it would be even more sensible that one would be very clear of what it's doing, and it takes in a span and it outs the memory of
so I think it needs to be clear, because I can imagine a scenario where I have a byte array, or I have an array.
Yeah.
I pass it to this method. I want to know when you suddenly swapped the array, or I still have to hold to the array that I had.
Yeah,
because I may be pulling the array that I passed you in.
Overlaps to figure that out.
I now need to call complicated overlaps APIs and do.
I think the fix-up would just always allocate. It would take in a span and it would out of memory.
So at that point,
and it would return thinking out to array.
No, at that point it would literally just return UTF-8 string. There's no reason for it to return anything else if it's allocating all this.
That's true. So that you would have essentially it would be the UTF-8 string of read-only span of byte.
So you mean the UTF-8 string constructor?
Yeah, that's the constructor was implicit in my head. It was so that's the fix-up. Assuming that you're doing FFFE.
Yeah, so basically the common scenario is I call try. If it fails, then I just create a new UTF-8 string.
Yeah.
I wouldn't do it a constructor because it would be nice if the method said I'm gonna be doing fix-ups for you.
Yeah. Okay, so it sounds like we see that we all agree on what the general shape of that method should be. We just need to massage what the parameters and stuff are to make it more useful. Okay. The only other thing that's in this document are operation status returning APIs. I don't know if that's interesting for this group.
It is interesting for me.
It is interesting for you.
Escape string.
Escape string is not actually listed in this document. Sorry. But things that you wanted, like 2 upper, 2 lower, are in this document.
Again, all that we care is that there's a copy of it in system text JSON. We don't care if it's public.
So we could review. So the operation status APIs that I have at the end of this document are 2 upper, 2 lower, and 2 upper invariant, 2 lower invariant, and also transcoding APIs.
The transcoding ones are interesting.
Yeah. The reason that I have separate transcoding APIs is to work around limitations of system text encoding.
Can you scroll down, Ivo?
I can as soon as I figure out how to get my cursor up into this thing again, yes. Which way do you want to
Scroll down until you see a large block of code with comments. There we go. So there's 2 upper, 2 lower. It's a typical operation status API. The 2 upper and 2 lower, if they're given ill-formed input, may return invalid data unless the underlying localization library says, I'm just going to try to do something. At which point we'll just say, okay, we defer to libicu or we defer to Windows in that case.
Do we have is file chunk in the middle for the basic 4 API, or is it always at the end?
I
Default
I
at the end.
think it's in the middle, but I'd have to get back to you on that. It will match whatever pattern that does.
Do we have equivalent in-place APIs?
For 2 up or 2 lower?
Mm-hmm.
No, for the reason that I mentioned earlier. It could expand or shrink, and I would corrupt the buffer at that point. What I would have to do under the covers is I would have to rent a temporary buffer to write everything into, and then mem copy everything back into the original source buffer. But if I'm doing that, I may as well just make that evident to the
Why
cover.
would you not keep going when you encounter a resize, undo the changes?
And then return I can't do anything at all? Because now I have to copy everything that I've overwritten just in case I need to back it out.
No.
Sorry, Levi,
The
what's
operation
the
is-
case where you would have to resize to be smaller?
Sorry, what was that, Steve?
So I'm trying to understand, is the concern that uppercasing or lowercasing may change the size of the character?
Yes, it could result in a longer or a shorter UTF-8 sequence.
It could actually result in a shorter. That's what I was
Yeah,
questioning.
it can result in either.
I still don't understand why we couldn't undo the changes.
The
We know
only-
how to upper and we know how to lower. When we encounter a resize, we just walk backwards and to upper or to lower, depending what the method was.
Well, if the original data was already lowercase, and you call too lower, and then I realize I have to back up, am I now uppercasing your data?
I'm stupid.
I'm destroying the original data at that point. The only way for me to recover is to make a copy, but if I'm making a copy, it wasn't in place anyway, right? So that's 2 upper, 2 lower.
Can encoding be done in place?
Encode? What do you mean? Oh, transcoding?
Yeah.
No, transcoding can't be done in place for the same reason. It can shrink or
In
expand.
one direction, it only grows, right?
No.
All of them will either shrink or
The,
grow?
the code unit count going from UTF-16 to UTF-8 will never shrink. However, UTF-16 is 16-bit bytes. So when you're talking in terms of actual amount of memory consumed, not code unit count, it can shrink or expand. The canonical example is ASCII text, right? The word hello in UTF-16 is 10 bytes, but in UTF-8 it's only 5.
Would it make sense to add a query method to ask whether it's going to resize or not, and then have in place APIs? Because basically the problem that I have is now we created API that basically forces data copy, but almost never the data copy will be required.
So there already are APIs on system text encoding to say things like how many bytes or how many chars will this thing result in. However, you still can't use that to perform an in-place update because maybe this part of the string shrank where this part of the string expanded. So maybe the total number of code units is the same in the end, but the string did a weird accordion thing. And as a result, I still need to make a duplicate under the covers.
So the API would not be is the size the same? Is can I 2 upper and 2 lower in place? That's basically it.
But if I'm already doing the case conversion work in order to give you that answer, why didn't I just do it into a temporary buffer and then say here's the buffer containing all the data?
Because the check can be done on basically runes. You don't need any buffers. You just keep walking and seeing whether there's anything that will require.
But this comes back to what Jeremy and I were talking about earlier regarding this API is now O of 2n.
Yes.
Like, why don't we just not have an in-place API and just say, look, the non-in-place API is O of 1n.
But the API won't be 2n because the user is going to do a check and call the API only that check was true.
And then what would they do in the else case?
They would call this API.
So now that's O of 2n as well.
But the point is, it's so rare. Or for example, I know my data is ASCII, and now I have to have copies between buffers, just to upper or to lower it. And it's so rare that this thing will be resized.
So if you know for a fact the data is ASCII, go ahead and pass in the same buffer for both source and destination. If you know the data is ASCII, right?
So you're saying it will? I can pass the same buffer.
I mean, if the data is not ASCII, like you're in for a world of pain.
Yeah.
But
well, it's not. It doesn't have to be ASCII. I can write. So should we provide a query that basically just walks it and checks whether it's going to be resizing? It seems to be useful.
My laptop died. Yeah. So Stephen.
Yeah.
And then I can code this API.
It seems like what you really want is an API which asks, is this data ASCII?
No, because it can be UTF-8.
What?
But
so what you really want is an API that asks, can this data change case in place? That would be a very difficult API for me to add, to be honest. Because I would be...
It can be conservative. It can be conservative. If there's even a single rune in this thing that requires changes in the number of code units, then you return false.
And no, it could also
very conservative.
It could also return the index where I found the first one.
The way that would have to be implemented is because it's using libicu or Windows under the covers. What I would have to do is under the covers, I would have to allocate or rent a temporary buffer to get libicu or Windows.
For invariant?
Even for invariant, yeah.
Make it super conservative, meaning don't.
Is ASCII. Is
well,
ASCII the only
is that the only one?
That's the only thing I can guarantee. But if you know is ASCII, then you could just pass the same source and destination.
Are we gonna have is ASCII, by the way, that takes you the read-only span of char8?
We could. I didn't have it here, but we could.
Then maybe that's basically If I had those two, because I'm thinking about common operations on like payloads of HTTP.
Yeah.
I kind of would prefer to just do many of them in place as much as possible.
We could have ASCII equivalents instead of UTF-8 equivalents that would operate on read-only span of byte, and those would just fail if they saw anything that wasn't ASCII. Especially since HTTP is a very specific scenario of yours, and HTTP, as far as the payload and headers go, are not UTF-8. They're generally ASCII. So maybe these APIs wouldn't be appropriate for your needs there. Because you want in-place updates, right? In-place transforms?
As much as possible. I mean, sometimes I know that it's not possible. There are some things that...
So maybe that's something we should just consider separately then, ASCII-specific transforms. Because honestly, those would even be faster than the UTF-8 ones. Because what they would do is they would simply say, you know what, if this data is not ASCII, I'm not even going to bother trying to inspect or fix things up. I'm just immediately going to return them. I couldn't do the operation you asked for. The only other things in here are transcoding APIs.
Can you scroll to the transcoding ones?
It's immediately after this comment. So it's from chars and to chars. Yeah, the transcoding APIs, there's replace invalid sequence, which basically says, if I see an invalid UTF subsequence while I'm doing the transcoding, if that is set to true, I'll replace it with the replacement character FFD.
But that's going against operation status. The operation status lets you return this was invalid data.
Yes, however, it makes it very difficult to consume because, okay, great, I returned you invalid data. What do you do? Like, how do you know what needs to be fixed up? If you just let me fix it up for you, it makes it more easier.
You're setting byte and consume.
Yes,
so
but
exactly where the invalid was.
Yeah, but how do you know what to do with that information once I give it to you? Like, say that I tell you, the byte at index number 52 represents the beginning of an invalid subsequence of UTF-8. How many bytes do you strip off in order to get to the next sequence?
Today if I pass to replace invalid sequence as false?
The user will see invalid data coming back and will probably just want to fail.
Same thing then without having the board.
What?
Like population status is invalidated alpha.
But if the user didn't want to fail, if the user wanted to recover by doing the normal substitution, the user has to have some ungodly complicated logic to figure out where to insert that character, which we should just do on your behalf. The reason for that is, again, come back to the scenario I mentioned earlier. Say that I return to you, I found the bad byte at index 52, and then you're now looking at these bytes, and you need to figure out how many of those to strip out, replace with a single FFFD character in the output, and then continue. The only way that you can do that correctly is to basically read the Unicode specification.
It's possible that I'm passing you partial data.
Yeah.
And that's why,
But that's what this final chunk is for. If you pass me partial data and I see an invalid sequence at the end, I'm not going to assume the data is invalid. I'm going to assume it's incomplete. If I see it in the middle, I'm going to assume the data is really invalid. And this can differentiate between invalid and incomplete anyway, in all cases. Like if I see an FF byte at the very end, I'm not going to return incomplete. I'm going to return invalid because I know that there's nothing you can ever give me after that that will ever make it valid. But it's really for convenience because I don't think the average developer can look at invalid data and know how to fix it up.
But this is not for average developers. Operating status APIs are not for those people.
I think without helpers, nobody knows how to fix it. Forget about average developer.
I don't think can do it.
But you're assuming that the user scenarios I want to fix it. Maybe they will follow a different code path.
And in that case, pass false, handle invalid data, and then do your own thing at that point. I think the common case is going to be the developer wants to do character substitution, and because I think that's the common case, we should just handle it on their behalf.
Do we let people pass the substitution character?
No, it's FFFD.
What does it stand for?
It's the diamond with a question mark in the middle.
So is that the official Unicode?
It's the official Unicode replacement character. Unicode also lets you, I mean, if they say that it's really implementation defined what you should replace it with if you see an invalid sequence. They really, really, really want you to use that very specific character, but maybe you use a question mark or something else. You know what? If you want that behavior, system text encoding is your friend.
Well, no, you can call this method and then replace.
You can't.
Why not?
Because similar to what I asked Asin earlier, how do you know how many bytes to strip out and how many question marks to write?
I call this method.
Yeah.
It does the replacement to diamond question mark, and then I call again replace, and replace all diamond question mark with whatever I want.
But what if diamond question mark was actually in the original payload? It's valid.
Okay, fine, it's not the same. But we are now talking about some very theoretical.
Diamond question mark is totally valid to be in a payload.
Really?
Yeah.
I very rarely use it for names
Maybe
of my
you
things.
But
somebody who's replaced invalid data gave you that data, now it has valid.
Yeah.
Sure.
Yeah, you have now mutated the data in such a way that it's no longer a faithful representation of what came in over the wire.
If you send people diamond question marks, you're a dick anyway. So
no, if I send people diamond question marks, I'm a red hat. Right?
This is gonna be my username from now on.
Or not a red hat, a black hat, a red teamer.
Diamond question mark? I think that's cool.
Whenever I start a new account somewhere, I'm gonna use diamond question mark.
So we have almost no time left.
Yeah.
So what are the next steps here?
So next steps are you mark this as API approved.
Yeah, I think right now I mark it as needs more work.
Well, yeah, I expected that. But I was hoping to get actionable feedback out of this, and I think I have gotten that for the most part.
Yeah, so I think on our end we still have to go through the motions to really define what it is we're shipping in 3.0. I think we have to do that with other. I mean, we have the same discussion with Jason, right? I mean, we haven't really done much for the serializer yet either, right? And you have to make some forward progress on what it is we need to expose. So, Christopher, on your end, how soon do you see yourself using any of this? Is this are we blocking you by not making forward progress, or is it just?
Well, what I said, I today use read-only span of byte, and I'm removing it on Monday because developers are starting, and I can deal with it, but barely. And I just realized, because I was actually yesterday debugging something with a developer who doesn't understand this whole thing fully, and she was so confused. She
I
was
can point you
looking
to a
at me,
YouTube
and
channel
she's
where we
like,
discussed this.
"What the heck is this, Christoph?" Like,
If only you were there when you designed the API for usability.
It sounds like there's another discussion to be had regarding very specific APIs that would make Christoph scenarios easier, which are separate from the APIs we've been considering here. And those APIs for your particular scenarios maybe should just be byte-based APIs.
but this one makes it like, let's say now it's available.
Right.
I would try again. I would basically now go back, change some places or add overloads that, on Monday will be taking strings, they will be taking read-only span of char8, and then I will attempt again.
Yep.
If I had this and literal support for strings.
But you need down level, right?
Yes.
Yeah, like that's I think the thing that we will have a hard time doing.
I don't, as I said, I don't understand why, but
Well, it's just we have to design it like that. Like,
sure. It's
like
just
for
a time
JSON,
issue
we can
because
probably get away
wasted
with
3
the
years.
source-based package. For this one, it will be a bit more tricky. But
So for UTFHR itself, we probably wouldn't be able to use a source-based package, but for the individual helper APIs writing on top of that, we might be able to.
yeah, but shipping just the type seems also weird. But yeah,
That's fair.
so the question is, like, do we have any upstream dependencies besides Christoph's theme?
Jason, so.
Sure, our own stuff doesn't count. Like, because we already.
Oh, our own team doesn't count.
Yeah. Like, is ASP.NET going to use any of this in Castro?
ASP.NET is everything's already on fire there. They're more interested in the actual exchange type things like UTF-8 string as opposed to this, because they're considering this from the perspective of how do we actually expose this to our overall developer audience.
Right.
I think they would find this interesting, but I don't see them using these all that often.
I suspect that they actually try to start doing work in this space. They would like this.
Yeah.
Because I understand that they are thinking ultimately what do we expose to developers, but they haven't yet written the internal code and have to deal with the things that everybody who will try to move their system to UTF-8 will basically give up after a while because you literally cannot debug code. Like, we've been talking like, hey, you can do these things. Well, they are not done, and today using read-only span of byte is literally not workable.
ASP.NET's priority, I think, right now is on making improvements and changes in the Kestrel. I don't think Kestrel is really going to use anything beyond byte as their own internal representation, which is totally fine, right? Because they're dealing with network data. But that said, I think they will find useful APIs similar to what Christoph needs, which is here is HTTP data I got that represents like an HTTP header or request line or something. Let me 2 upper or 2 lower this thing in place, right? Like I'm going to assume for now this is ASCII because it's what the HTTP spec says. Those APIs I think are going to be more universally useful. Unfortunately, they're not presented here.
Anyway, I need to run.
Yes, thank you for your time.
Yeah, thank you.
If you wanted more context on any of this, like feel free to read the wall of text in here.
Yeah.
So
I've taken notes. I think I've captured most of the stuff. Like towards the end, I was not quite sure because I was like writing other things at the same time. So I will submit a PR, and then you can just add the other things that you remember. And then I think we have a good first cut of notes.
Yeah, like being that I'm generally a security person, like I guess a lot of the way that I approach this is if we do use read-only span of byte for everything, like what are the potential pitfalls of that? So I do spend some amount of time in the document discussing those, including historically how it's caused problems.
Right.
That doesn't mean that we won't end up doing that in the end. It just means that we need to be aware of the fact that pitfalls exist. How do we avoid them?
Right.
If we want to go down that path.
Well, I think that's generally the trade-off, right?
Yeah.
Like,
I also tried looking at Go to see how they handled all of that, especially with regard to UTF-8 security. And A lot of that seems to be, it's an application level concern, not a framework level concern.
In what sense?
Like the application developer, if they care that the UTF-8 that's coming in from the wire is well formed, they should do that check themselves. Granted, the framework, the Go language, the Go SDK, like does provide the facilities for them to perform that check, but it is still a check that the application developer explicitly has to take. Go generally looks like they just expect all of those. They just expect strings to be slices of bytes.
Right. They're not relying on the type system to indicate something.
Right. Well, they are to an extent. Like they do differentiate between string and byte slice.
Sure.
That might change in the future, but at the moment there is that
But that's
distinction.
also because they're string by default UTF-8.
Well, it's the real reason is that they don't have a concept of read-only slices. So you can't project a string as a byte slice because now all of a sudden it's mutable. If you had a read-only slice, they actually have an interesting discussion they've been having over the past few years. If you had a read-only slice type, could you project a string as a read-only byte slice? And I don't think they've quite settled on an answer, but it is something they're very interested in pursuing. And as far as I understand their most recent thoughts around that, the implicit projection from string to read-only byte slice, that projection would be implicit. There would be no projection in the opposite direction. The reason being that they want string to be not just an immutable representation of data, they want string to be an immutable representation of immutable data, if that makes sense. And because there's no way to guarantee that the read-only slice is itself immutable, because someone else could have a reference to it, then at that point string now becomes mutable, which leads to a whole slew of problems.
All right, let's end the live stream at this point. We'll find the button to do that. Bye, guys.